All right, I got 10-10. Let's go ahead and get started. So I put a bunch of review stuff on Canvas on this week's module. So review website, which if you went to it last time, it's no different than the link I posted last time. Practice quiz full of like 30 or so questions from past tests. Some problems from the textbook that are relevant. But yeah, just a reminder, take a look at those things before Monday. Most, if not all of Monday is going to be review for y'all. Any questions on that? Okay, so been talking about sequences and specifically convergence and divergence of sequences. So let's get back into it. So a couple of theorems that can kind of help us out here. I'll just kind of scroll through these and I'll describe them, give you a chance to take in the notation. So the first one I'm going to talk about is the limit continuity theorem. And so basically what this is, you can think of this as kind of the function composition version of sequence convergence. So basically, if you have a sequence that converges to some limit, then if you have some function that's like acting on that sequence, so basically if that function, or sorry, if that sequence is the input to some function, then that function has to take on the value of whatever that limit is. So I understand these are going to be a little more difficult to look at or to think about until you see some concrete examples, but wanted to show them to you first. So basically, if you have a sequence that converges, then basically if you have the function act on that sequence, the function will tend toward, it will basically converge to whatever f of the limit is. The other one is the squeeze theorem. I think, in my experience, I think this is a little more intuitive for folks, but let's talk about it anyway. So you have three sequences here, A, B, and C. And what do I know about these sequences? I'm assuming that A is the smallest, C is the largest, and B is always in between them. So if that's true, so basically I have three sequences that kind of do this. Like here's A. You know, I'm graphing these as solid lines, but we know they can't really act like that. Here's C. And then I don't know what B looks like, but I know it's always between them, right? If A and N, or sorry, if A and C have the same limit, then what does that say about the limit of the one that has to be in between them? That has to have the same limit as well. So let's look at a couple of examples of each. Any questions? So these are very much in the abstract right now, but any questions on the way that I've described them so far? Okay. So let's take a look at this one here. So any predictions about whether this thing converges, what it converges to, just by looking at it? Yeah, I got to vote for 0. How come? Or 1. How come? So how are you getting to that? How are you getting to 0 or 1, wherever you're landing on? So the thing you just mentioned had nothing to do with the sign, right? So you can kind of break these things down. If we look at A sub n being this sequence, pi over n, let's just leave the sign function out of it for now. Does that sequence pi over n converge? It should converge to 0, right? So I have a constant pi in the numerator. The denominator is going to grow without bound. So that's going to trend towards 0. So that inner function or that inner sequence converges to 0. So because of that, what does this converge to? this converges to the sine of 0, which is 0. So basically, we said this explicitly, that basically this inner function, this inner sequence is pi over n, but we also have some like outer wrapper function, which is what? How can I define that function f? Because really what I have here is f of a of n, f of a sub n is equal to sine of pi over n. So by default, what does f have to be? Has to be sine of x, right? Is f a sequence? Can I say that? Are the things going into f, are they going to be integers? Now, many of the pi over n, none of those are going to be integers. So I had to, f is really and truly a real value to continuous function. So final limit here we got is 0, also the same as that intermediate limit for just the sequence. How are we doing so far? All right. How about this thing here? One thing I want to point out here is I think this is the first time I can talk about it. So this is a sequence, right? The ends in this are always going to be whole numbers. They're always going to be integers. Is this a function that I can talk about? By the way, what does the exclamation point mean? Factorial. So like, I suspect it's rusty for at least some of you. If I write 5 factorial, what does that mean? Basically, it's the product, it's descending product, counting from 5 all the way down, which I think is 120. What is pi factorial? It's nonsense. So in this case, we talked about this like L'Hopital's rule workaround for a lot of these sequences last time. This doesn't exist here. I cannot talk about factorials where the domain is the real numbers. It doesn't make any sense. So because of that, we have to have some other way to think about the limit of this function. Any predictions on how this is going to go, or any suggestions on how to look at this so we can get some kind of idea? Go ahead.
You just try to figure out which one grows more.
That's the real issue, right? If you can figure out which one grows faster, if factorial grows faster, then what's true about this sequence? It goes to infinity. It'll diverge. And if n to the n grows more rapidly, then it'll probably tend towards 0. It'll converge to 0. So let's do this. I have no idea the way it's written. So let's focus on what these things mean. What does n factorial mean? Well, it's n times what? N minus 1 times n minus 2 all the way down to 2 times 1, right? What does n to the n mean? Okay, so, but I'm trying to keep this generic, right? So how many n's are there going to be in the numerator or denominator? N times n times n. How many of these are there going to be? An amount, right? So basically, this is what this sequence kind of looks like. I have to abbreviate it because I don't know how big n is. But now that I've written this, do we have any kind of intuition about what's going to happen? So I like the way that it was put before. Figure out which grows faster, the numerator or denominator. Should be the denominator, right? How come? Why is the denominator going faster? right? So all these factors, so let's get rid of these. All these factors, basically, if I pair these up, the factors on top, or the factors in the numerator, are going to be less than the factors in the denominator. So let's try to do this. Let's try to bookend this. So basically, we have this sequence, B sub n, which is the one we care about. So what I would like to do with this, I would like to set up like this chain of sequences. Where A is the smallest, C is the largest, and B fits right in between them. Because if I can get that A and C converge to the same thing, that means B better converge to the same thing. We've already kind of talked about, like, this is kind of a 50-50, or maybe not 50-50, but we got one of two outcomes here. Either this thing diverges because it gets infinitely large, or it converges to zero. And it sounds like now we're leaning towards what? Should converge to zero, right? Because the denominator is growing larger or growing more rapidly. Could I say this is true? What if I called A sub n 0? Is 0 a sequence? It technically is. It's a very non-interesting sequence, but basically what A sub n looks like is this. All the terms in it are 0, 0, 0. It's a constant. It's kind of like the function f of x equals 1. Is that a function? For all x values, f of x equals 1. For all n values, a sub n equals 0. In b sub n, is every term going to be positive? Is n factorial going to be positive? Is n to the n going to be positive? How come? I'm only looking at n equals 1 and beyond. So I'm only dealing with positive numbers, so I can think, I can call a sub n 0. How about this? Can I say that c sub n equals 1 over n? So here's 1 over n, right? This very last term. Is the rest of this stuff going to be less than 1? I think it should be, right? Because let's take them, like, let's pair them up. What's bigger, n minus 1 or n? N, so this would be bigger or less than 1? Should be less, right? Times less than 1, times less than 1, and so on, right? Does that make sense? Sure, try again. Go ahead.
Why is a sub n equals 0?
Basically, I'm making a choice here.
Okay.
So I want to know about the convergence of b sub n, which is this. So basically, what I'm trying to set up here is that squeeze theorem. B sub n is this very complicated thing that's hard to think about. So if I can prove that there's two sequences A and C that are really simple, or at least more simple, and then B is right in the middle of them, then that might tell me something about their convergence. So before we get there, I want to make sure that this is true. Is A less than B? So is 0 less than this n factorial over n to the n? I asked you a few minutes ago if that was positive. B sub n is always positive, right? So I think I get A sub n is less than B sub n. Is B sub n less than C sub n? So basically the question I'm asking is this: n factorial over n to the n, is that less than 1 over n? Or I guess equal to it. So that's what I was kind of getting at here. If these things are all less than 1, then multiplying that by 1 over n has to be less than 1 over n, right? Go ahead.
How did you decide on C sub n?
That's what I was kind of walking through there, is that I know that 0 converges to 0. because it's a constant sequence. That's the only term in that sequence. I know that 1 over n, actually, I haven't said it yet. What do I know of the sequence 1 over n? Anything? Does it converge? It should converge to 0, right? I think, did we look at that exact sequence last time? Or something like it? But basically, I know that the limit as n approaches infinity of 1 over n, I have a constant 1 over a variable n that's going to keep getting larger. That's going to keep getting smaller and smaller, trending towards 0. So that is why I am suggesting we choose this a sub n and this c sub n. Because now basically what I have is this. I have 0 is less than or equal to n factorial over n sub n to the n, which is less than or equal to 1 over n. It is not 0 because, so a couple things that they're subtle, but they're different and important to talk about. I'm not saying 1 over n equals 0 there, but it does converge to 0, right? So a couple things here. There's a difference between talking about what happens for like any given value of n versus what happens if I let n go to infinity. So this thing right here, I'm not dealing with a limit for this. I'm just looking at, all right, for every given value of n, will this chain be true? Let's pick a value of n, let's say 3. If n equals 3, then I get 0, which is less than or equal to, what's 3 factorial? 6 over, what's 3 to the third? 27, which is less than or equal to 1/3. Is that true? I think this middle one's like 2/9. Yeah, 2/9 and 1/3 is 3/9. So just one example, but any value of n, like that chain of inequalities will be true. So now what I want to think about is this. What's the limit as n approaches infinity of 0? That should be 0. All the terms in that sequence are 0. What's the limit as n approaches infinity of 1 over n? 0. So if the largest sequence and the smallest sequence both converge to 0, and there's a sequence that's always right in the middle of them, what does it have to converge to? Also 0. So this is how the squeeze theorem works. Basically, if you can find an A sequence and a C sequence that are way easier to think about, that behave this way, you can get, like, you can look at the convergence of those simpler sequences. This converges to L equals 0. Questions there? Ask me all of them. What?
How did you choose a C of n? Like, if you already knew that the limit converged at 0, what's the point?
So if I already knew that what limit was 0.
Like, you said the limit of n to infinity is, it converges at 0, right?
Well, we had two options, right? Basically, here's what we didn't know for sure. We have a numerator and denominator. They're both going to increase. Basically the thing we had to figure out was which increases more quickly. Okay. That I don't think we had any. I mean, we didn't really have anything better than a hunch until we came up with those bookend sequences, the least and the greatest, and seeing that they basically track the middle one into 0. But yeah, I think with sequences, the reason I'm asking is kind of like for your intuition first, because that can kind of guide you a long way. It's not a good place to make an argument from, but it's a good place to start thinking about it. Good question. What else? All right. Let's talk about a very specific type of sequence here. R to the n. So basically R is going to be a constant. N is the variable of a sequence. For what values of R does this sequence converge? So let's make a number line here. So R is going to be a real number. Give me a value of R. Let's try it. 3 sounds good. So if this sequence is 3 to the n, then what's in that sequence? 3, 9, 27, 81. What does this sequence do? Does not converge. So I think for 3, we have no convergence. Does that suggest anything about maybe, I don't know, 7? What do you think happens when R equals 7? It'll go to infinity even quicker. So I think 3 and above, I don't have convergence. So let's throw that out. Let's kind of focus on things that are less than 3. Where do we think this will actually converge? 0, 1. So let's try 0 and 1. If R is equal to 0, so 0 to the n, what does this sequence look like? Doesn't it basically look like the one we just dealt with? So I think at 0, I have convergence. What about for 1? That's another constant sequence. So 0 to 1, and I'll kind of fill in the blanks here. Everything between 0 and 1, you're going to get convergence for. What about like 1.5? Or 1.1? It's going to go to infinity, right? Anything bigger than 1, if you start taking powers of it, it's going to go to infinity. So definitely between 0 and 1, the negative numbers converge. Let's look at -1, for example. If I have -1 to the n, what does that do? -1, 1, -1, 1. Is that convergence? Why is that not convergence? It does not, like, it's bounded. It does not, so it does not like trend to any single value. So basically, here's what you get for convergence with this kind of sequence. Does anyone happen to remember what kind of sequence this is? There's a very specific word that kind of defines these things. No, not just the alternating, but just sequences where I have like some number constant raised to a power of n. So to answer the question that I put forth here, here's our range of values from -1 to 1, including 1, but not -1.
Why are we using the negative numbers between 0 and 1?
Why?
Yeah.
Well, let's do one.
So we know it also switches between positive and negative.
Let's see. What's -1/2 to the power of n? What does that sequence look like? -1/2, 1/4, -1/8, 1/16. What's going to happen here? You're right, they're going to alternate, but they're going to alternate around. They're going to alternate around 0. Eventually, they're getting closer and closer and closer to 0. So that's why I include the negative numbers. The name for these kinds of sequences is geometric. So basically, a geometric sequence is defined by, if you just lay out all the terms in order, if I can multiply by a certain value to get from one term to the next, and that value is constant throughout the whole sequence, that's called a geometric sequence. So how do I get from 3 to 9? Multiply by 3. How do I get from 9 to 27? Multiply by 3, and so on. So very common type of sequence to look at for, and they converge for, under very, very specific conditions. Basically, it all has to do with this R, which you might have heard this term, common ratio. Basically, that common ratio is the number you can multiply by one term to get the next term in the sequence, no matter where you are in the sequence. Questions so far? All right. So another vocabulary term I want to throw at you is monotone sequences. What does it mean for a sequence to be monotone? Basically, it's one of these two options. If you have a sequence that's increasing or decreasing. So an increasing sequence, basically what that means is every term in the sequence is not smaller than the one before it, but it could be as large as the one after, or the one that comes after it, but basically it has to be this weakly increasing thing. If one term in the sequence is 5, the next term in the sequence has to be at least 5. It could be identical to 5, but it has to be at least 5. Decreasing sequence is a similar idea, kind of in the opposite direction. As you move through terms of the sequence, they have to be getting, basically, they have to be weakly decreasing. I cannot go from this term to a larger one. Questions? All right, what about bounding? So just like with monotone sequences, there were 2 kinds of monotone. There's 2 different kinds of bounding. It's either bounded above or bounded below. So basically, what does bounded above mean? Bounded above means that there's like a maximum for your sequence. There's some number that exists where all of the terms are smaller than that number. Or that value or smaller. Bounded below means your sequence has a minimum. If you just say your sequence is bounded, what does that mean? It means that it's both. It's both bounded above and bounded below.
So there's a maximum.
Yeah. How are we doing? So I just threw a bunch of terms at you. How are we doing with them? Or do you not know how you feel until I throw some examples on top of them? Okay. So let's look at some. All right, so let's just ask these questions. So -1 to the n, is it monotone? Okay, let's go to bounded. Is it bounded? Right, so here's the thing. If you tell me it's bounded, you better be able to tell me like these bookends. Give me a number that is less than or equal to all the values of that sequence. Is there one? -1 and 1, do those work? Is this a mathematical symbol we all know? Then I won't use it. It basically means for every n. So is that true for every value of n, that sequence will be between -1 and 1? I think so. I think that is true because this sequence, what does it look like? -1 to the n. What's the first term? -1, next term. And just indefinitely oscillates back and forth, right? So yes, I believe it's bounded, and I believe it's bounded between -1 and 1. Is it monotone? What does that mean? It's either one or the other, increasing or decreasing. Is it either one of those things? Can't be, right? It alternates. An alternating sequence means that, so this is going to increase from first term to second term. decrease from second term to third term. So that's enough to say no. Thoughts, questions, protests? All right, go again. How about this thing? What do you want to talk about first, monotone or bounded? Monotone. Any ideas so far? So I think, I don't know if I brought this up last time, but I think a very good idea to kind of just get your bearings about these things. Look at the first several terms of a sequence and see if you can understand anything about it. What's the first term of this sequence? I'm going to write it unreduced, but 3/6, and then 3/7, 3/8, 3/9, 3/10. Does that give you any kind of intuition about? It looks like it's decreasing to me, right? So I'm going to say yes. More specifically, it decreases. It might not go to 0.
Okay,
So right here, that's a good question. When we say monotone, we're not saying it has a limit. So let me give you a really simple, silly sequence that's monotone decreasing. A sub n equals negative n. That's decreasing, right? Will it converge? No. This one might. We'll talk about that in a second, but yeah, monotone does not tell you if it converges. It might not. So we said monotone, yes. How about bounding? Do we think this thing is bounded? You say no.
That's 0, right? It's just bounded.
So what does it mean to be bounded? Let's talk about that first. It has to have. So we said it's decreasing, right? If it's decreasing, it should have to be bounded above, right? Because that means the first term is the biggest. If it's decreasing, the first term is the largest. So I think I can say this sequence is bounded above by a half. So the question really becomes, is it bounded below by anything? I got some votes for no.
Should be bounded below that because it can't go past 0, right? Or like below 0.
Are all the terms in this sequence going to be positive? They better be, right? So because of that, I can say that 0 is a bound below. Yeah, so if it's a decreasing sequence, by the way, let's make sure you're all okay with that. If we have a sequence that's decreasing, does the first term have to be the biggest?
Oh, yes.
By definition, it has to be. Because the next term, the next term could also be 1/2, but what's not allowed is for any of the other terms, any of the following terms to be larger. So do I have bounding? Yeah, I was able to found a lower bound and an upper bound. Go ahead.
What are the cases where it's only upper bound?
Sure. In fact, the one I just gave you here, is that, so we said that wasn't bounded, right? The negative n. Is it bounded on either side? Is it bounded from above or above or below? I think it's bound. I think the biggest number in this negative n here is -1. Because we have -1, -2, -3. So yeah, it can be bounded on one side and still be unbounded. So to be bounded, it has to be bounded from above and below. So this thing is monotone and bounded. Does it converge? Let me ask you this. does monotone and bounded always mean convergence? So in this case, we had a decreasing sequence. So if it's always decreasing and we know there's a point that it can't go past, does that mean it has to converge? So hold that thought for a second. How about this one here? Is it monotone? How do we know? The denominator is growing faster than the numerator, right? So it might be decreasing, but let's look at some terms. 1/2, 2/5, 3/10. Are those decreasing? Yeah, I think so. So now that I've written down some terms, what do we think? Should be decreasing, right? So yes, decreasing. Is it bounded? We definitely know it's bounded by from which side? From the top, from above, so 1/2. So if we can come up with a bound on the bottom, a bound from below, should be going to 0. Here's something else, like even if it's not going to 0, can I say safely it'll never reach 0?
Yeah.
All these numbers are going to be positive. So on the last example, it seemed like most of you said that if it's monotone and bounded both, it'll converge. Does this one still support that thinking? Yeah, this one doesn't prove that one wrong. It'll converge to 0. Is this thing monotone? Yes. Which way? Yes, it increases. Is it bounded? Bounded from the bottom. Is that enough? How come? Right, just be bounded on both ends. Does it have a bound from above? No. Does this one converge? Nope. So this is a theorem that book calls the monotone sequence theorem. I like to call it the monotone convergence theorem because it's a little more on the nose about what it actually does for you. But basically what it says is this, is that I'm now confirming that your suspicion was correct. If you have a sequence that is both bounded and monotone, it is convergent. So that is always the case. So if you have a sequence that's bounded and monotone, it has to be convergent. Does that mean that a sequence that is convergent has to be both bounded and monotone? Give me an example.
-1/2 squared.
-1/2 squared?
No, to the end.
To the end. Let's write out some terms. Oh, did we do this one before? This was familiar. Is this thing bounded? Yeah, I think it's bounded. Bounded below by what? I don't think 0. -1/2 to 1/4. That'll work. By the way, this is kind of silly, but you can also say this. This is bounded between -2 and +2. Is that also true? It's kind of a lazy way to say it's bounded because I didn't really look for the best cases, but that's true. So this thing is bounded. Is it monotone? It's not. Does it converge? It should converge to 0. So one thing to just keep an eye on here is that, yes, every sequence that is both bounded and monotone converges, but if you have a sequence that converges, it doesn't mean that the other two you get for free. How we doing? Okay. Do I have? Yeah. Let's do it. So that's sequences. Oh, that's cool. So this next section is the last one we're going to talk about in the test. We might go a little bit further depending on where we end up on Friday, but as far as the test is concerned, we're gonna end here. So now we're going to talk about infinite series. So let's talk about how these things are related. So we've talked about sequences a lot, right? So a sequence is just it's an ordered list of numbers. We can also talk about the sequence of partial sums. So let's kind of give a concrete example here. Let's just say that, let's just do this sequence, the counting 1, 2, 3, 4, 5 sequence. If this is kind of like my base sequence, I can build another sequence called the sequence of partial sums that behaves this way. Basically, every term in this sequence is the sum of the first that many terms in that like base sequence. So what's the sum of the first one term in A? What is it? Yeah, basically the sum of the first term. I'm asking it kind of a, it probably sounds weird to hear me say it that way. It's simple, it's one term, right? But the reason I'm saying it like that because now it's going to become more meaningful. What's the sum of the first two terms? 3. And then 10, and then 15. So sum of the first one term, sum of the first two terms, 3 terms, and so on. But the thing we're really working up toward is what a series is. So a sequence of partial sums is a sequence where I'm adding up the first several terms. What is a series? A series is the sum of how many terms? All of them. How many terms are in a sequence by definition? I didn't do a good job capturing here. An infinite number. So for a series to converge, or let's back up to what we've been talking about. For a sequence to converge, you're really just looking at like the tail of it, right? You're just looking to see what the terms do as you go far out, and you want to see if they get close to something. Series, it's based on sequences, but it's based on something a little different. I don't want to just look at what the terms are. I want to know about what happens when I add them all together. And if I add them all together, which, you know, it's kind of an impossible thing to think about because there's an infinite number of them, but if I add an infinite number of terms, it comes out to be a number. It converges to something finite. So still dealing in sequences, but now we're looking at their sums instead of just the items that exist in them. Questions so far and some new terminology I'm throwing at you.
The series is just add the sequences?
Yeah. Adding up all the terms in the sequence.
But how do you add? Is the series-
Same like, so I'm not trying to be flippant, but like think about an integral, like a Riemann integral. How do you add up all those rectangles?
It's just
Right, but it's the same.
like,
So we can't do it, like it's not possible to do it, but like there's a thing in calculus we use to help us think about what's going to happen if. So basically what we're looking at is a limit here. So basically, as you think about an infinite number of terms, is there some kind of tendency that we're getting close to? So this one here, I don't think have we talked about this thing before? Let's unpack this notation, make sure we're okay with it. What does that notation signify there? I just mean the whole symbol. It's a sum. So let's talk about what we're adding together. What does the I equals 1 signify? Yeah, basically like the lower bound, the first value of n. So basically what I have here, everything in between the equal signs here, they all kind of say the same thing. I mean, they have to, but packaging in different ways. If I add up the first n terms in the sequence, and I guess that's one thing we gotta talk about here. Is this the way it's written? This thing right here I'm boxing in, is this an infinite series? So technically the way that's written, it's not infinite. That counts up to some n value. But if I'm going to ask if this series converges, I want to know about this, the limit as n goes to infinity of this sum. So from I equals 1 to n of a sub I. So how can I look at that? What do I know about the sum of these? What do I know about these partial sums here? For example, can I figure out what the first term in the sequence is? So if I just look at A1, two over 8, because basically this right here tells you how to find the nth partial sum. What if I add up the first 4 terms? What do I get? So are you trying to figure out 4 individual numbers?
Yeah.
You don't actually need to do that. That's what I wanted to make clear about this thing here. This right here is the nth partial sum. So the 4th partial sum is whatever I get when I plug in 4 to the ends. So 8 over 17. Yeah, that's the partial sum. It is so, yeah, so I think we'll stop this example right here because I think there's more we have to unpack, but that 2n over 3n plus 5, that does not tell me how to get a term in the sequence. That tells me how to get the sum of the first n terms in the sequence. I mean, when you want to get the first term, it's the same, but other than that, it doesn't work that way. So let's stop that example there. We'll pick it up and we'll deal with this convergence next time. Otherwise, I'll see you Friday. Reminder, I have office hours today from 1:30 to 2:30.